Hello everyone, I am Dr. Mohammad Nadeem, Assistant Professor at Department of Computer Science, Aligarh Muslim University, Aligarh. I teach and learn artificial intelligence, data science and machine learning. In the next few weeks, we will discuss about machine learning, its types and applications. So let's get started. The content of the week are as follows. We will talk about what do we mean by machine learning. We will talk about the different types of machine learning paradigms which are there. We will be focusing more on the supervised learning techniques. We will talk about some very famous supervised learning algorithms. We will also talk about the implementation of these algorithms using Python and some very famous Python libraries. In today's lecture, we will be focusing on these key points. We will first discuss what do we mean by machine learning. We will discuss its type, and we will also discuss the two very famous categories of supervised machine learning called regression problems and classification problems. So what is actually machine learning? So even though AI has achieved new heights, one of its criticism was that a machine cannot be considered intelligent if it cannot learn from its past experiences. And historically, machines were deemed unintelligent because they could not perform tasks they were explicitly programmed to do. They lacked the capacity of learn and adapt. This perspective sets the stage for the importance of machine learning as a revolutionary step in making the machines intelligent by enabling them to learn from data and improve over time. At this point, it is important to discuss what do we mean by learning itself. So learning in the context of machine learning means the copying the human ability to grow and adapt based on experience. It is not just about executing a task, but about doing it more efficiently and effectively with each new attempt. This concept is fundamental to machine learning, where algorithms adjust and improve their performance as they are exposed to more data over time. So, overall, machine learning can be seen as the science of getting computers to act without being explicitly programmed. That is, focusing on developing algorithms that enable computers to act or make decisions based on data rather than through explicit programming. This approach allows machines to learn from the experience. It allows them to adjust to new inputs and perform tasks with minimal human intervention. A hallmark of machine learning programs is their adaptability also. So unlike traditional static programs, these algorithms can adjust their strategy based on the new incoming data, leading to continuous improvement and the ability to handle very complex and dynamic problems. It is also important to mention that machine learning in the end needs data. So the quality, the quantity and diversity of data directly influence the learning capabilities and performance of these algorithms. Data serves as the raw material from which insights are derived, patterns are recognized, and decisions are made. An important and obvious question that comes to our mind: why do we need machine learning and why there are, so many reasons? One of all, there is a difference between learning and memorization. Learning involves understanding the patterns and making predictions based on the new and unseen data, while memorization simply refers to recalling a specific task. Earlier, AI systems were oriented more towards memorization, but machine learning prefers the learning and aims to generalize from the past experience to make intelligent decisions in the future. Moreover, earlier we did not have much data to learn from. The modern age has brought us lots of data from social media interactions to sensor networks. This wealth of information is the basis of machine learning. One of the strengths of machine learning is its ability to process and make sense of large and complex data sets. It tries to find relationships and insights that would be impossible for humans to identify manually by themselves. This capability allows for more accurate predictions and decisions. Finally, the core objective of machine learning is to identify patterns within data. By recognizing these patterns, algorithms can make predictions about future events, they can understand trends, and provide insights to make more informed decisions. Let's see a few examples. A practical example of machine learning in action could be the friend suggestion feature on the social media platforms. So, by analyzing the user interactions, their common interests, and mutual connections, algorithms can recommend new friends to enhance the social network experience. Machine learning also powers the recommendation systems like those used by online retailers and streaming services such as YouTube. These systems try to analyze your past behavior to suggest products or content you might like and provide you personalized browsing experience. Another everyday application of machine learning is in your spam filtering in your emails. So by learning from thousands of the previous emails, algorithms can accurately separate out the spam email with the normal messages and make our inboxes safer and more manageable. So these are only a few applications of machine learning in action. Now let's talk about machine learning and its type in detail. There are a few categories of machine learning. The most famous is the supervised one. So what do we mean by supervised learning? It is a method where the algorithm learns from example, means previous data, and input and output pairs both are given to you. So in the case of supervised learning, we have x values as well as y values. X is the set of independent variables and y is something that we want to predict. It is similar to a student learning under the guidance of a teacher, where the correct answers are provided during the learning process. Next comes the unsupervised learning. Unlike the supervised learning, this method does not rely on the labeled outcomes, the y values. Instead, it identifies the patterns and relationships within the data itself and offers insights into it. So in unsupervised learning, we have only a set of independent variables, if you will. That's why I'm writing only x here, but we do not have any corresponding associated value with that, which is y. We will discuss these two in detail in the upcoming lectures. Then we have reinforced or reinforcement learning. Here, algorithms learn to make decisions through trial and error method. This learning rewards the desired behaviors and penalizes the unwanted behaviors. In reinforcement learning, every action leads either to reward or penalty. Therefore, the algorithm tries to learn options that lead to reward and ultimately win and avoids penalty which leads to loss. One of the major applications of reinforcement learning is in games where one player is human and the other player is an algorithm. So reinforcement learning primarily works on the concept of reward and penalty. Lastly, semi-supervised learning sits between supervised and unsupervised learning. It utilizes a small amount of labeled data alongside a larger set of unlabeled data. Let me remind you that supervised learning is also called that it contains the label data because it has X, and unsupervised is called having unlabeled data because it doesn't have the corresponding Y value. So semi-supervised learning has some labeled data and a larger set of unlabeled data, making it particularly useful when obtaining the labeled data is difficult and expensive. So semi-supervised learning utilizes a small amount of labeled data alongside a larger set of unlabeled data, which makes it particularly useful when obtaining labeled data is difficult and expensive. Now let's talk about supervised learning. Supervised learning Now let's talk about supervised learning. Supervised learning is one of the most commonly used machine learning technique and part of many applications we use daily. In supervised learning, the algorithm is trained using a data set that contains inputs paired with the correct outputs. So we have the example data, the input part, and the associated outputs are also available. It is like having a teacher who provides the questions as well as the answers. These input-output pairs enable the algorithm the relationship between them, and this is the primary purpose of supervised learning. Now, once trained, the model can predict the output for new unseen data. This ability to generalize from training data to new situations is a powerful tool for everything from spam detection to predicting consumer behavior. This learning process is similar to how we learn from others by following examples and guidance. It emphasizes the importance of having accurate and high quality training data for effective learning. The more accurate the training data is, the better predictions can be made. Once again, think of supervised learning as classroom teaching, where students learn concepts through examples provided by the teacher. Similarly, supervised algorithms learn to predict outcomes based on the examples they have been trained on. Let's discuss a few more examples to make it more clear. So example that you are seeing on your screen is an example of supervised learning. Now, why it comes into the category of supervised learning? If we focus on this part, it is the X part or input part. What this problem is all about? This problem is that we have been given the data of previous years where a company spent some money on the manufacturing cost, some money on the advertisement cost, and they got some sales. So sales here is the Y value. Now this data tells us that given this much of manufacturing cost and given this much of advertisement cost, the company makes this much in sales. So in a way, the sales is dependent on this pair of input. We have such a data for different years available. Now, if somehow we can identify that how the sales, that is Y, depends on the manufacturing cost X1 and X2, if we somehow can identify this relationship based on the previous data available to us, then maybe we can predict what will happen in future also given the manufacturing cost and advertisement cost. So for example, if we learn from this existing data set the relationship between sales and manufacturing and advertisement cost, then maybe for 2024, given some manufacturing cost, given some advertisement cost, I can predict how much sales the company can make. So this is a typical example of supervised learning. First of all, we have been given the existing data set where we have both pairs, the input pair and the output value. We have to identify how output depends on the input values so that in future, if only the input is given, I can predict the output. Let's consider another supervised learning example. Here, given the email, so we already have this set of previous data, and we know that when this was the text of the email, it was an spam email. And when the text of the email looked like this, it was not an spam email, and we have thousands of these examples. We are given the text, we know whether it is a spam email, and given the text, we know that it is not an spam email. Now, can we develop the relationship between text, which we are representing as X, and Y, which we are representing whether it is a spam or not? Can we establish a relationship between X and Y so that when the next time some email comes in the inbox, we can actually predict whether it is an spam email or it is not an spam email. So this relationship we try to learn in the case of supervised learning from the previous or existing data set. Once again, it comes into the category of supervised learning because we have both. We have the set of independent variable and the class or the label or the outcome that we want to predict represented as Y. Now, how supervised learning works? In supervised learning, we first start with the training process, and training process involves feeding an algorithm with the examples from a data set. And each example in the data set consists of an input-output pair, where the output is a label provided by a supervisor. So each algorithm might use its own training method, its own learning method, but once trained, the algorithm can now make predictions for future. Also, the core idea of supervised learning is very consistent, but the approaches can vary significantly. Algorithms like linear regression, logistic regression, decision trees, artificial neural networks each have unique ways of interpreting data and learning from it. Supervised learning tasks can be broadly categorized into two categories, regression and classification. In the case of regression, we predict a continuous quantity. We will see that with the help of one example soon. And in the case of classification, the Y value is a set of discrete values. It is not continuous in nature. Let's highlight a few major algorithms in supervised learning. Linear regression finds relationship between the variables for prediction. It is used for regression problems, and rest of them which are mentioned here, that is logistic regression, decision tree, and artificial neural networks, they are primarily used for a classification task but can also be used for regression tasks. Out of all of them, ANN is a type of machine learning technique which can be used for both regression and classification quite easily. So we will discuss these algorithms in detail later. Now, once we have discussed supervised learning, which means our data has both the X values, the set of independent variables, and the Y value, the dependent variable, we can further categorize into two broader categories, regression and classification. First of all, the data set here is a supervised learning data set because we have X and the Y that we want to predict. But in this specific case, you can see that the Y value or the output is continuous in nature. That is, it can take any value in a certain range. So Y value here is a real value. That's why this specific supervised learning problem will come under the category of regression. So to conclude, regression is one when the y value of the supervised learning is continuous in nature. Let's take a few examples. One of them we have already seen. So given the manufacturing cost and given the advertisement cost on a specific year, in a specific year, what is the sales? Obviously, there's an example of supervised learning first of all, because we have x as well as y, but here y is a continuous variable and it can take any real value. That's why it is a regression problem. Let's take one more example. So given this data set, the question is how much rain will fall in July this year in Mumbai. This is once again an example of regression problems because we have the set of x, we have y, it is supervised, but the y value is a real number. It is not fixed to a limited number of values. It can take any value in a range. That's why it is a regression problem. Often the regression data looks like this, where we have the x values in the 2D plot. Here we are using only one independent variable and the corresponding y value, and the objective here is to learn the relationship between x and y, whether it is a linear relationship, that is when x increases, y increases as well, or it is some other polynomial relationship that exists between them. But usually the regression data looks like this. And the objective is to identify what is the relationship between x and y in terms of whether it is a linear relationship or any other type of relationship is there. There are many regression variations, that algorithm related variations, but these three are very common. Let's go them one by one. So linear regression assumes a linear relationship between independent variable or input and the dependent variable or output. So the formula here is y, and this is how y depends on x. It is beta naught plus beta 1 x plus some level of error, which is written as epsilon here, and it is called a linear regression relationship. Then we also have the concept of polynomial regression. Here the assumption is that the y may not be linearly dependent on x, as it was the case in the case of linear regression, but it might be dependent on the higher order terms of x as well. So it is not only beta naught plus beta 1 x, but it might also contain higher order polynomial terms like x square, x cube, and so on. And here also there are chances of error, which we have written as the epsilon. Then we have the concept of multiple regression. So far in linear regression and polynomial regression, there is only one independent variable, that is x. Here we have power terms, but the independent variable is only one, that is x here. In multiple regression, we can have two or more independent variables and only one single dependent variable. So we have only y here, but we can have multiple independent variables. So x1 is a separate variable, independent variable, x2 is a separate independent variable, and so on. So these type of relationships might exist between the set of independent variables and the dependent variables, and depending upon which type of regression this one is, linear regression or polynomial regression or multiple regression, the process of identifying the relationship between them might differ from one another. Then on the other hand, the other broader category of supervised learning is called classification. Let's remind us once again that here also we have the xy pair. So it is a supervised learning data set. But if you focus on the y values here, there are only a fixed number of values that these y values can take. So it can be class 1 or class 2 only, that's it. So it cannot take an infinite number of values, any real value, but rather it can take only a discrete set of values, in this case class 1 and class 2. Let's consider a few examples of classification also. So given the humidity and wind speed and temperature, whether we can play the game or no. So it is an example of classification problem. Why? Because there are only two values possible, either yes or no. It is not like regression where you can have any value within the range, right? So the y value here is not continuous, it is discrete in nature. Another example, given the patient details, we want to predict whether that patient has cancer or no. So we have the set of x independent variables and y the dependent one. But in this case, we can have only 1, 2, 3 different values. Previous case, there were only 2 values possible. In this case, 3 values are possible, but still a discrete set of values are possible. It is not like continuous where any value is possible within the range. That's why it also comes in the category of classification problems. Now, in the case of classification problem, the major objective is that given the data set, can we differentiate between them? And usually we come up with a curve that separates one class of examples with the other class of example. And this curve here, which is a line in this specific case, is called a decision boundary. But in classification, this decision boundary separates the positive examples with the negative examples, or examples of one class with the examples of other class. So in summary, we have covered following topics. We discussed what do we mean by machine learning. We discussed its type. We saw the further categories of supervised machine learning, that is regression and classification. In the next lecture, we will discuss a popular algorithm called linear regression. Thank you.